Okay, Assalamualaikum dan good afternoon. So now we continue our discussion about the combination basic flow patterns. Now we are focusing on doublet, here doublet. Okay, so but before we know about doublet, we should know about the combination of source plus sink, because doublet is actually it starts from the combination of source and sink. Okay, so what is source plus sink and what is the combination patterns? Okay, because previously when we combine linear and source, we know we can have Renkan half body, and I hope you could draw the patterns. You know the rule of thumb about the streamline. So means streamline for source will not cross the border, and as well as the streamline of linear flow will not cross into the source streamline. So it will flow on its own line. Okay. So what happened if source plus sink? So first, please imagine that we have source and sink. So normally in default situation, so we will have source on the right here, and we will have sink on the left like this. So and then we know that source is something that the flow will comes out from one hole, but sink is the reverse of the source. So means that sink is it will receive all the flow here. It will receive all the flow so into one point. Okay. So in this situation, okay, as your friend asked me just now, the flow rate here, the M, because source will have its own M and sink here will have its own M. So in this situation, so we assume that the strength of sink and source is equal. Why? Because if it's not equal, so the sink cannot cope with the flow rate of source. Or if the source is too slow, so mean the sink here will not receive all the flow at all the time. Okay, yang ini awak kena faham, di dalam sink and source, kita beranggapan bahawa kadar alir akan sama untuk sink dan source, kerana source perlu mengeluarkan 10 meter per second, meter cube per second, dan sink juga perlu menjedut dengan nilai yang sama, 10 meter padu per second. Sekiranya source terlebih banyak, maksudnya akan ada air yang tidak akan disedut oleh sink, ataupun sink terlebih besar, so kita kata air akan disedut secara tidak sekata. So dia akan boleh merosakkan keadaan lah. Okay, so jadi kita kata dalam keadaan ini awak kena imagine bahawa kekuatan sink dan source adalah sama. So kemudian awak imagine bagaimana untuk melukis flow pattern, combination of this flow pattern. So let's say we have source here, and the nature of source is dia akan mengeluarkan aliran. So anak panah akan keluar. So di dalam sink, so awak kena imagine pada dasarnya source akan keluar mengikut jari tegak gitu. Tapi disebabkan oleh sebelah sini dia menyedut, dia menyedut aliran, oleh itu garisan yang tegak ini lama-lama akan terbengkok sedikit untuk disedut masuk. Dia akan berbentuk bulat seperti ini. So kita gambarkan bahawa flow pattern combination between source and sink adalah seperti ini. Okay, memadai untuk awak melukis garisan yang lebih tu macam inilah. Okay, tetapi awak kena tunjukkan anak panah daripada mana dia keluar dan daripada mana dia masuk. Okay, boleh So jadi maknanya awak kena imagine apa yang berlaku di sini. Dia adalah satu aliran yang keluar dan disedut masuk di sebelahnya. Dan for this combination, you must alert with X and Y axis. Okay, because okay, tak apalah, nanti saya tunjuk. Okay, kita by default kita akan menggunakan X axis. So ini adalah X axis. So kemudian kita akan cuba we try to give a mathematical expression and mathematical terms for this one. Okay, and then the mathematical diagram will become like this one. So mean that if we have source here, and source will release a flow, and then this flow is actually sucked by the sink here, and then we could draw a circular line like this one. So, and then we imagine that we have one particle here. So we stated as P. So, and then we connect a line between sink and source here. And finally, we give them the angle here. Okay. So this is the one. And then I think I could make it a little bit faster here. You have an idea how to start your psi combination. So psi combination is actually the sum. You add all the value of psi that you have. So because we have only two, source and sink, so we add source and we add sink here. So the equation will become like this one. So we have, because the m here is constant, as I said, the strength of source must be equal to strength of sink. Okay, to make sure that the flow in is equal to flow out actually. So we could write as m over 2 pi delta theta 1 minus theta 2. Okay. Okay, that is the basic idea about the about the uh, about the combination of sink and source. Okay, so now we go for doublet. So doublet is quite special because, okay, first, previously we know that if we source here and we have sink here, we will have that pattern. And this pattern is actually will will become the same if the sink and source is separated by any distance. Maksudnya di dalam keadaan di mana sink dan source terpisah dengan satu keadaan, dengan satu jarak, dia akan memberi bentuk ini. Tak kira lah jarak ini dekat atau jarak ini jauh. No matter whether the distance is near or far, so it will give this kind of pattern. That's it. So means there are no interesting. So the interesting one is what happen if sink and source meet each other at one point. So yang menarik perhatian pengkaji ialah apa yang akan berlaku sekiranya sink dan source bergerak mendekati antara satu sama lain dan satu ketika seolah-olah berada pada satu titik yang sama. Okay, awak kena ingat bahawa kita mempelajari tajuk ideal flow. Ideal flow ni adalah satu tajuk yang bermaksud, salah satu maksud dia adalah dalam keadaan imajinasi. Ideal flow means flow without friction. So and that in real world there are no flow without friction. Okay. So means kita anggap, that's why kita kata kita boleh menganggap apa akan jadi sekiranya dua titik itu secara matematiknya kita ingin menganalisa berada pada satu titik yang sama. So it will become like this. So the stream function here, the streamline here will become absolutely round. Maknanya absolutely in circle shape. Okay, tadi dia akan jadi agak bulat juga, tetapi tidak, dia ada terbuka lah di sini. Okay, tetapi sekiranya sink dan source ini bergerak antara satu sama lain dan duduk pada satu titik yang sama, dia akan berbentuk bulat seperti ini. So saya harap yang ini awak dapat ingat. So let's say kita masih lagi beranggapan bahawa source di sebelah kanan, oleh itu anak panah kita buatlah daripada kanan ke kiri. Okay, so yang ini yang agak menarik perhatian kerana apa? Sekiranya sink dan source berada pada titik yang sama, okay, kita perlu ubah equation ini. Kerana apa? Kerana theta 1 dan theta 2 merupakan theta yang sama. So jadi tetapi kita tidak boleh simply kata, okay, because dia berada pada titik yang sama, theta dia adalah sama, so theta 1 tolak theta 2 will equal to 0. No, if you put a 0, so everything is 0. So means you collapse all the calculation. So semua akan jadi kosong. So tak ada makna. So jadi itu sebab doublet menjadi satu tajuk yang menarik kerana kita kata ada tricks nak menunjukkan bagaimana pengiraan boleh dibuat. Okay, so kemudian lagi satu ialah di dalam tajuk doublet, okay, please make sure that you understand the formation of doublet. So means sometimes, for example, in this diagram, so I'm showing you the patterns, okay, for doublet on x-axis, okay, because previously it stay here and here, So it's moving toward each other, and then when it's stay at the same point, so it will become like this. So and in y-axis, so you need to draw like this one. Okay, walaupun di dalam aplikasi yang lain tidak memberi banyak efek, tetapi secara di peringkat awal saya harap awak benar-benar faham tentang perkara ini. So as I said, the combination will become, we need to do something with the psi combination here, because at this situation we may assume that theta 1 is equal to theta 2, which is equal to theta. So means that we cannot simply say that theta 1 minus theta 2 is equal to 0. Okay, what we need to do? Okay, so we need to do like this one. Okay, let's say. So this is actually from the previous diagram, okay, I'm sorry, the previous diagram like this one. Okay, I just cut the location and I only show you the important point. So this is the P, and then because we are using polar coordinate, so the coordinate is R and theta. And this is theta 2 and this is theta 1. Okay, this is theta 2, this is theta 1, and then you need to imagine to create a doublet. So you need to move theta 1 and theta 2 towards each other. So means if you move toward each other, so they will meet at the center point O here. Okay, awak boleh nak gerakkan satu aja kerana both flow, source and sink will have both sink and source have same flow rate. So maknanya kita terpaksa gerakkan di dalam keadaan hal laju yang sama, oleh itu dia akan bertemu pada satu titik tengah. So the center point here is shown as 0. Okay, let's say. So and then we make this line, okay, because we want to show the angle of theta 1 and theta 2. So and then, so this is the new line. The line where the source and the sink meet each other. So and then we create an imaginary line of this one and this one. Okay, by assuming that this length is actually same. Maksudnya dengan jarak yang sama kita melukis satu line dan kita akan hubungkan dengan satu garis lurus. Okay, kerana apa? Kerana kita ingin membuat persamaan dan kita ingin mengambil advantage. So if this value is equal to R, so mean this value is also equal to R and this value is also equal to R. Because kita anggap dia jadi satu bulatan lah. Okay, boleh imagine So saya harap awak dapat imagine yang itu bagaimana gambar rajak ini dibina. Oleh itu, okay, sekiranya di sini adalah Q, theta 2, theta 2 and this is theta 1, I think you could imagine that the angle here is theta 1 minus theta 2. Okay, you may do this at home, the relation of these two angles. Okay, now we start our calculation. Okay, you already know the angle here. Okay, so from basic calculation of psi combination, we could say that it is psi source plus psi sink. And then we could simplify it as m over 2 pi theta 1 minus theta 2. And according to this situation, to this idea, we could replace the value of theta 1 minus theta 2 here equivalent to alpha. Okay, because in this one, we try to simplify. So instead of we have theta 1 and theta 2, so we assume it is equal to alpha. Okay. Okay, here. Okay, now we like to neglect the existence of theta 1 and theta 2. That's why we need to create an assumption. So we have an alpha. So and then from the diagram above, we could say that R alpha is equal to X plus Y. So from where this comes from? So the idea is, as I said, so because we imagine this is the radius. this is the origin, and it moved like this one. So this is also radius, this is also radius. So mean the r theta means r is in radian. Okay, so r theta mean it is almost equivalent. So because the we assume that the changes is very small, so it is okay for us to imagine that it is equal to these two straight line, x and y. Okay, so that's why we write here r alpha is equal to x plus y. And then we manipulate the value of x plus y by using the idea of trigonometry. So we could get that, okay, x is equal OB sine theta 2. So if we see this one, so it is OB. So we have a theta 2 here, and we could use the idea of OB to get the value of x. And then finally, at the same method, we could get the value of y here, okay, because we already have the value of theta 1 here, and also the length of OA. Okay, so and then I hope you could imagine that after okay, saya besarkan lagi lah supaya dapat yang ini je. Okay. Okay, that's why we write r alpha is equal to x plus y, and this is actually reflected the value of x, and this is reflected the value of y. So and then we bring the value of r here to the right hand side, so we have this term. So and then because now we imagine our sink and source is at the same on the same point. So we assume that theta 1 is equal to theta 2, which is equal to theta. So and then we replace the value of theta here. So because the theta here is the same, so and then our equation will become sine theta over r plus at times OA plus OB. So we have OB and OA here. So we have OA plus OB. And then OA plus OB will become AB. So this is actually the calculation based on that diagram, because certain students, they start to ask what is the fundamental of this one. This is actually showing you the length. So you know that, okay, you have the OB here plus OA. So finally you will get AB. Okay, this is AB. Okay, so actually we are calculating that one. So that's why we have here the OA plus OB is equal to AB. So now alpha is equal sine theta over R A times B. And I'm sorry, A to B, the distance of A to B. So and then we could replace like this one. So let's say from previous calculation, we found that psi combination is m alpha over 2 pi. So we substitute with the alpha, sine theta over r a b. So and then we could rearrange a little bit. We have a sine theta r here, and then we have m a b over 2 pi. Okay, the problem is actually start in here. We have an m a b. The idea is, okay, sometimes mathematics will not give you a correct answer. Mathematics is not reflecting the real one. So for example, at this situation, we found that MAB is actually reflect the strength of sink and source. However, if sink and source is on the same point, means the AB here is equal to 0, suddenly the psi combination will equal to 0. So it's totally wrong. It's totally wrong. Why? Because we try to make a mathematical expression to represent a real world. But if your mathematical expression cannot represent the real thing, so means your mathematical expression is incorrect. So you need to change into something else. You cannot say that, oh, my mathematical expression is correct now, means that the real world is fake. It's that the real world is actually, I don't know why this real phenomenon occur. So that's not the idea of engineers. So means in this situation, we found that if AB here is equal to 0, so it will give us a 0 for everything. So means it's not reflect the real situation. So what we need to do is, okay, we just make an assumption here. So we just make assumption here, which is the M over AB here is actually the strength of doublet. Okay, because we want, that's it. We don't have, we just don't want our equation, our parameter can be turned into zero. Okay, alasan dia mudah aja. Kerana di dalam equation ini, kita dapati bahawa ada possibility untuk AB menjadi kosong. Dan once AB menjadi kosong, dia akan rosakkan semua sekali. Okay, tetapi apa sebenarnya physical meaning of M times AB? So M times AB ini sebenarnya dia melambangkan strength of sink plus doublet, sink plus source. Oleh itu, okay, saintis yang terdahulu mengambil keputusan bahawa di dalam matematik kita ubah terms M times AB ini kepada strength of doublet. Kita beri dia terus kepada satu formula ataupun satu terms. Jadi itu kita ubah. Kita tak menggunakan lagi MAB, kita hanya menggunakan nilai mu. So nilai mu ini akan bermaksud strength of doublet. Okay. Cuma di sini kadang-kadang ada berlaku kekeliruan di antara banyak buku teks. Ada setengah buku teks yang dia akan mergekan lagi. Dia kata 2pi di sini actually constant. Why not kita biar 2pi ni duduk luar? So ada setengah buku dia akan tulis bahawa M doublet ni adalah katakan A equal to a times sin over R. Dan A ni adalah strength of doublet which is equal to mu over 2pi. Awak faham So oleh itu, daripada pengiraan ini, kita boleh dapat lagi satu basic flow patterns. Tadi permulaan kita ada 4, kita ada linear, source, sink dan vortex. So setelah kita menggabungkan sink dan source, kita keluar, kita boleh dapati satu lagi psi untuk doublet. Oleh itu psi untuk doublet worth untuk awak ingat sebagai salah satu basic flow pattern. So doublet is mu 2pi r, mu over 2pi r sin theta.